going to go on and get started. We're going to look at the homework question number 8. So we're wanting to perform the given operation. We're wanting to find the sum, or in this case, the difference between these two here. Now, since the denominators are the same, we can subtract the numerators. So in this case, we're going to subtract 4x squared and 1, giving us 4x squared minus 1. Now at this point here, we need to see if we can simplify, if at all possible. And 4x squared minus 1 is a difference of perfect squares, because we will have plus and minus. Because 1 times 1 will give us our 1, and 2x times 2x would give us our 4x squared. At this point here, we do have something in common on top and bottom. 2x minus 1 and 2x minus 1, leaving us with 2x plus 1. You get to the 4x squared minus 1? Oh, yeah. Yeah, and then it's just... yeah. And then the other one we wanted to look at was 20. You want to look at 20 through 26? Any questions on 8? Are we good to move on from 8? All right. Now 26, I'm going to look at here. X plus 3 was originally over x squared minus 25. But I went on and factored the x squared minus 25 just to make things a little bit nicer. You know, move that over a little bit. Now we need to find the least common denominator for this here. And if we look at each of the terms, to get them to be the same, for us to be able to add or subtract, well, one of the terms that I see that's in common with all three is x minus 5 and x minus 5. It does show up at least once in each of the denominators, so that means we're going to need it at least once in all three. And the only one that's missing the x minus 5 is our one on the far right. Another term that we have is x plus 5, and since it only shows up once, we'll have to multiply the other two by x plus 5. And lastly, the only other term is x plus 3. So we have all three of these here for the denominator, x plus 3, x plus 5, and x minus 5. Now we're going to have to distribute and multiply these through. X plus 3 times x plus 3 will end up giving us x squared plus 6x plus 9. Because if we do the multiplication through, the x times x is x squared. X times 3 is 3x. 3 times x is 3x. Well, our 3x and 3x will give us 6x. 3 times 3 is 9. Now the middle, I would multiply two of these at one time. I would not try to do all three at once. It's a little much to do at once. We'll do the x plus 5 times x plus 3, which will give us x squared plus 8x plus 15. I know I'm jumping steps there. X times x is x squared. X times 3 is 3x. 5 times x is 5x. Well, our 5 plus 3 does give us 8. X, and 5 times 3 is 15. Now, out of all of these here, the last ones we have to multiply. X plus 5 times x minus 5 is x squared minus 25. Now this last one here, we need to multiply the x squared minus 25 by 3, giving us 3x squared minus 75. And the first one's going to be x squared plus 6x plus 9. The middle one will get x cubed plus 8x squared plus 15x minus x squared minus 8x minus 15. I went on and just multiplied that out because it's few too many terms for me to try to keep straight in my head. Or try to do it all at once. At this point here, all we need to do before we can actually add and subtract is make sure we just combine these like terms. 8x squared minus x squared is going to be plus 7x squared. 15x minus 8x is going to be plus 7x minus 15. There we go. In some way, there's a little bit cheating in it. Now, at this point here, we can drop the parentheses, and it's going to just flip all the values of our middle term from positive to negative or negative to positive. I always start with the variable with the biggest exponent, negative x cubed. Well, That's the only one that's cubic. Now we have x squared minus 7x squared, which gives us negative 6x squared, plus 3x squared gives us negative 3x squared. 6x minus 7x. Yep, 6x minus 7x is negative x. And lastly, 9 plus 15 minus 75. Well, 15 minus 75 is going to be 60. Negative 60 plus 9 is going to be negative 51. Questions on this here before we start factoring? Yep. We're ready to factor this. Yes? Awesome. There is a way to factor these. It's called factoring by grouping because we can group them together. But there's no way to factor it by grouping. That's as simplified as it gets. So it's not so much that this one is harder than the rest. It's just a lot of terms. It gets really big. And then it does simplify down. But yeah. I will tell you this, especially when we get a lot of these terms at the bottom, I'll fill in just a given term for it so I'm not having to repeat the same thing over and over again and then remember to put it back in. All right. Simplifying complex fractions. There's two ways we can do this. One is getting the numerator and denominator as a single term, and then simplifying that fraction, or using a least common denominator. So when we look at this here, there's two different ways we're going to do this. We'll do both methods first, and then I'll let y'all pick from there. Now the first method, I would watch, and then we can do the second method together. Now the first method wants us to get the numerator and denominator of this fraction as a single fraction. Now the numerator is fine as it is, because it's just 5 over x plus 4. That is a single fraction. However, the denominator is two fractions. So we want to write them as one. We actually need to add these two fractions together to give us a single fraction. So we need the denominators to be the same here. So with both of these fractions, we're going to have to multiply the top and bottom by an expression or a fraction to get the denominators of the denominators of the denominator to be the same. For the one on the left, we're going to have to multiply it by x over x. The one on the right, we're going to have to multiply by x plus 4 over x plus 4. Now the numerator is going to stay 5 over x plus 4. Our denominator here, 1 times x is going to be x. On the bottom, we're going to have x times x plus 4 plus. Here on top, we'll need to multiply through by 2. Our 2 times x is, and 2 times 4 is 8. Now that the denominators are the same in the denominator, we can add them. So we'll have the same denominator, x times x plus 4. On top, we have x plus 2x plus 8. Now, since we're adding the numerators, we really don't need parentheses. Really, we would put them around each term, but they would just drop. So at this point here, yes, we do need to simplify the denominator's numerator, because our x plus 2x is 3x plus 8 over x times x plus 4. So we got the first main goal that we got it, one fraction on top and bottom. But part of the issue with this is that we can't have fractions in fractions. Now a fraction is just another way to say that we have a term, the numerator, which is being divided by the denominator. Really, that's all a fraction is, the top of the fraction divided by the bottom. Now, here, a little lower than that. Nope, not what I wanted. There we go. That's what I wanted. Now all we need to do is solve this division problem. Because 5 over x plus 4 stays the same. We can change it from division to multiplication and flip our second fraction. Now at this point here, we'll multiply them together. Luckily enough, there is something in common. The x plus 4 and x plus 4 telling us that we have 5x over 3x plus 8. Now before we can say we're done, is there a greatest common factor between 3x and 8? No. And there's no way we can, since we can't factor anything out, we can't reduce anything on top and bottom, giving us this here. Questions on this so far? All right. We're going to do this again by method 2. Now, luckily, as I said, watch the first way. Let's do the second. So, and the reason I say that is because the first way isn't bad. It's a lot of steps. It's a lot to keep track of. Yes? Second way. Least common denominator. Least common denominator. So we're looking for the least common denominator between the denominators in the top and bottom of this fraction. What is one of the terms that shows up in the top and bottom? One of our factors. X plus 4. How many times does it show up? Once. It shows up in 2 places, but only once. Any other factors that we need? X, because x is the only other factor in the bottoms of the fractions on the top and bottom of this fraction. That is a sentence. So, what we're going to do is we're going to take this and multiply the top and bottom of this fraction by the least common denominator. Now for the top of this fraction, the x times x plus 4, again, it's going to multiply with this top fraction. And when we do, it's multiplying with the top. So we're going to have 5 times x plus 4 over its denominator, which was x plus 4. On bottom, we're going to do the same thing. Our x times x plus 4 is going to multiply with the 1, which will give us 1x times x plus 4. Or we can just say x times x plus 4. And lastly, we're going to multiply the x times x plus 4 with 2, giving us 2x times x plus 4 over x. Okay. Questions on this so far? Now we're wondering why I said most students prefer this way. Let's see what happens. On top, x plus 4 and x plus 4 cancel, yes? That's the only thing left on top. Okay. Let's look at the bottom. Here, x plus 4 and x plus 4 cancel. Here, the x and x cancel, leaving us with x plus 2 times x plus 4. We do have some simplifying to do because we still need to distribute that 2 through. 2 times x is 2x. 2 times 4 is 8. X plus 2x is we can say we like this way better, yes? And after seeing the first way, it's annoyingly simple compared to it. That's why I normally say watch the first way, let's do the second way. First hour today I said that, and they swear I didn't. But, because again, both ways work. Both ways get to the answer. One's a little bit longer. I think we like this way better, yes? So if we look at this one here, least common denominator. What are we going to need to be a part of it? Well, x minus 2, because it does show up at least once in the denominators in the top and bottom of this fraction, and x. Now, since the x minus 2 only shows up once, we only need it once. Now, if we had x minus 2 squared, we would need it twice. But we don't have x minus 2 squared. We just have this here. I need to make these a little smaller. So on top, we'd have 6x times x minus 2 over our x minus 2. On bottom, our x times x minus 2 is going to multiply with our 1, giving us x times x minus 2 over x minus 2. And we're going to multiply the x times x minus 2 by our 3, giving us 3x times x minus 2. Questions on how we got to this point? Yes? No? Okay. You're good. If you ever need me to scroll back up or slow down, just say something. Just hold your hand up. So, let's simplify. X minus 2 and x minus 2 on top is gone. X minus 2, x minus 2, x and x. Leaving us with 6x on top. On bottom, we have x plus 3 times x minus 2. And our 3 times x minus 2, 3 times x is going to be 3x. And rewriting that 3x. Minus 6. Well, x plus 3x is going to be 4x minus 6. Six x is as simplified as it gets because it's one term. 4x and 6 is their greatest common factor. 2. So we can factor the 2 out, giving us 2 times 2x minus 3. Now, since we have multiplication, we don't just have addition and subtraction, because the 4x minus 6 is being subtracted, so they're stuck together. We can't do anything with it. But now that we have 2 times our 2x minus 3, that 2 and 6, if they have common factors, are going to reduce. Well, yeah, 2 and 6 do have a common factor of 2, which tells us that the numerator is 3x and the denominator is 2x minus 3. Questions on this here? Questions on anything we've done so far? We're ready for the next one. X over 6 minus x over 3 all over x minus 5 minus 7 tenths. Yeah, might need to write the least common denominator out for this one. Because this time we're finding the least common denominator of 4 numbers, yes? Oh, wait a minute. What is the least common denominator between 3 and 6? Yeah, 6. I can turn 3 into 6, and we're good there, yes? How about 5 and 10? So even though they gave us 4 numbers, we're really only looking for the least common denominator of 2. And that's something that is helpful, especially if they're asking for least common denominator or stuff like that on the ACT. If you notice 2 of them turn into each other, we can remove 1 out. So instead of trying to look at the least common denominator of 3, 6, 5, 10, we just look at 6 and 10. And its least common denominator is not going to be 60. It would be what? 30. 60 is a common denominator, but it's not the least. So we multiply the top and bottom of this fraction by 30. 30 times our x over 6 is 30x over 6. 30 times our x over 3 is going to be 30x over 3. 30 times our x over 5 is 30x over 5. And 30 times our 7 over 10, 30 times 7 is 210. Luckily, doing that's not too bad, because if we know 3 times 7 is 21, add the 0 for 30. Now we need to simplify. 30x over 6, 30 divided by 6 is 5x, minus 30x divided by 3 is 10x. 30x divided by 5 is 6x, and 210 divided by 10 is 21. 5x minus 10x. Yes, negative 5x. 6x minus 21, can we combine those? Is their greatest common factor? Yes. 3. And it's going to leave us with 2x minus 7. That's it.
So when we multiply the 30,
Yes. Because even though it is a fraction, really what we're looking at on top and bottom, so just the question is when we multiply the 30, we only multiply in the top. So I'm just going to take this here and pull it to the side. Because really what we're looking at is x minus 5 minus 7 tenths. This is being multiplied by 30. So even though it does look like we have it as a fraction, that 30 is going through the bottom.
Okay.
So really,
If it was 30, it would just be 30 over 1.
30 over 1, so it's still multiplying with the top. Yes, because it feels like fractions we should be applying it to the top and bottom, in which we are, but that fraction isn't the fraction 30 over 30 here. Let me get a highlighter. This here isn't being multiplied to so much these fractions here, but the big fraction as a whole. So when it hits each of the fractions in the numerator and denominator, it's just our individual 30s, not the whole fraction. Does that make sense? Yes. Yes. Mm-hmm. Yeah. So that's, again, that is something that can sometimes be confusing because we are multiplying it by 30 over 30, but when it hits, here just 130 is going to the top, 1 is going to the bottom. So it looks more like this here than it does as a fraction. It's just 30 times our 1, so it just multiplies through the top. Does that make sense? Questions on these here? How do we feel about these here? We feel good? We'll do one more. I will let y'all pick which one, because there are multiple that we have left.
This second last.
This one, or was it this one?
The one.
This one.
Yeah.
Okay.
Yes.
Because I don't think this one's on there.
No.
No. Okay. So, least common denominator. But we do have x and y showing up, yes? So, x is a factor. How many times does x show up in any of the denominators? Because we do have it showing up once in the middle, yes? But on the far right side, it's showing up how many times? Twice. So we will need to multiply through the top and bottom by x squared. We also do have y. Also showing up twice, so we're going to have to multiply through the top and bottom by y squared. So we're going to have to multiply through the whole thing by x squared and y squared. So our x squared, y squared is going to multiply through the top. Well, x squared, y squared times 1 is x squared, y squared over y squared. Minus, when we multiply it with our middle one, it's x squared, y squared over xy minus, well, 2 x squared, y squared over x squared. Questions on this so far? Good so far. Nice job. Now in the denominator, our 1 times x squared y squared is just going to be x squared y squared over y squared. Minus 3 x squared y squared over xy plus 2 x squared y squared over x squared. Yes, a lot of terms are about to simplify. I'm going to start on the ends because the ends are a little bit nicer. Because in the top, the y squared and y squared will cancel, giving us x squared. Here, y squared and y squared giving us x squared. Minus, minus. We'll put the 3 here because it'll still be here. Plus, not plus. Because this here is going to be a minus. This will be a plus. We'll still have our 2. Here, our x squared and x squared's gone. So on bottom, we have 2y squared. X squared and x squared are gone. 2y squared. Because those it nicely cuts out or cancels out completely. The middle on top, the x squared y squared over xy, well, one of the x's and one of the y's will simplify, leaving us with xy. Same thing is true for the bottom. 1, 1. For me, when it doesn't simplify out completely, I'll mark out the ones that do simplify out and change the exponent to its new number. So it's changing it from 2 to 1. So we have this here. Both of these factor. So if we look at the top, the third term is negative, so the signs are opposite. Only factors of x squared are x and x. The number in front of it's 1. Now we need to find the factors of the third term, 2y squared. Well, the only factors of y squared are y and y. Now we just need to figure out where we want to put the 2, with the positive y or negative y. And we can check this here. X times negative y is negative xy. 2y times x is plus 2xy, giving us a positive xy. Correct number but wrong sign just means we need to switch the signs, which will tell us that we have positive xy minus 2xy, giving us the negative xy that we wanted. On bottom, the third term is positive, so the signs are the same and match the sign of the middle term. Only factors of x squared are x and x. Factors of 2y squared, well, y squared is going to be y and y. 2 and 1. And if we check this here, x times negative y is negative xy. Negative 2y times x is negative 2xy, giving us negative 3xy. Questions on how we factored this? Now it does look different than how we, or what we would expect to factor, but it does still factor. And it factors the exact same way we would normally factor, which is nice. That's why I like that method. And that's it. Questions on this here? Funny thing for the restrictions for this, especially at the end, is that x can't equal y. Because if they are the same, that thing's going to be 0 on bottom. Yeah, so it's essentially by the time you're done, you can say that the restrictions are x is not 0, y is not 0, and x can't equal y. But are y'all ready for the assignment? (39, 40, 42, and 44).